Uh, okay, good afternoon, everyone. Welcome. I guess this is the beginning of the third week of Intro to R. Thank you for joining again. So far, we've sort of run through getting started with R. We've talked about the different data types, different data structures, talked about what functions are, how you can set them up, and some of the kind of major functions like apply, for loops, if else statements that you may use. We also touched upon some of the things with data cleaning around things like the tidyverse for sort of manipulating your data and making changes that way. Today, we're going to continue a discussion we started on Tuesday about data visualization, primarily focusing in on heat maps. And depending on where we are for time, we might talk a little bit about Gplot2, which is a package for kind of more for making figures that you might put in a paper or on a poster, whereas what we talked about last week and what we'll be talking about with heat maps, while you may, of course, put heat maps and histograms and things in a paper and poster, we're really talking about from the data exploration side of things. And so less focusing on kind of the, how to customize them to make them look nice, and more how to get visuals that you can get insights from that can then help you make decisions about what types of analysis will be appropriate, what sort of trends are existing sort of under the surface of your data that maybe wouldn't have jumped out at you had you only looked at, say, a table of numbers or only run analysis. There's also a few links that were forwarded over to me by Dr. Fenyo of good options for good things to be aware of with data visualization. So I'm actually going to put those, I think, in the chat, but I'll make sure to do that again. I recently found out that the chat is not retroactive, so people only see what they've seen up until they've signed in. So I'm going to put those in. So those who are here now will be able to see them, and maybe enjoyable reads. Oh, whoops, I only sent that to one person. And okay, so just to reintroduce myself, my name is Fred LaPolla. I'm a librarian at the Health Sciences Library. We have a bunch of great TAs on the line in the chat. So as I'm talking, yes, that's a great idea to post them in the Slack. If you run into questions, definitely feel free to ask in the chat or on Slack, but probably for right now, the chat is going to be the best option. The other thing I'll note, which I've noted in the past is, but I think maybe especially relevant today with heat maps, since we're really kind of sort of skimming the surface of more of the RNA-seq analysis. So my background is not in bioinformatics. So the things I'll be talking about are less about, I'll be able to explain less the why of certain decisions and more the technical features that may go into them. And that said, some of the things we'll be doing will ultimately come down to kind of making, kind of informed professional decisions. Some of the things we'll be doing will come down to what makes sense as you're exploring your data based on your understanding of your sample set. And I'll sort of highlight that as we move forward. So the first thing we're going to do is we're going to actually pull in a new data set, not the same one we've been working with, although we did sort of touch upon this at the end. So feel free to copy this. And again, remember to do this sort of one section at a time. So library to curl, URL to the end after CSV with the end parentheses, and then the name of this. And this comes from Dr. Dolgolev. This is real data looking at, this was the counts, normalized counts of, they did wild type and knockout mice. And so you can see that there, hopefully, to be able to pull that in. So again, so yeah, just to, as we might always do, I've done a head command just to sort of actually see what I was saying. So we've got the names of the genes over here in this first column, and then the normalized expression counts and the specimens at the top. So we can see they're not quite necessarily in the order, they're not all together with the wild type and the knockouts, but they are sort of wild type, and then the knockouts in the middle. So as we discussed now a few sessions ago, a very important first step after we've sort of just seen what we're even talking about is going to be to check out the class of what we're working with. So here we can see it's a data frame, which I'm not 100% certain it's true that everything R reads in from a CSV will read in as a data frame, but in general, that has been my experience. And so the work we'll be doing today with matrices for heat maps rather are going to require that we change this into a matrix. Did I skip one? No. So for me, and this isn't, again, totally necessary, but I actually wanted, and maybe I'm just being sort of overly uptight about it, but I kind of wanted to just group them visually by type of specimen, so wild type versus knockout. So something we can do relatively straightforward, just as a first step after we've pulled it in and assessed what type of data we're working with. So I've gone ahead up here and I've reordered my data. So the first thing to note is we've taken the same data frame and read it onto itself. And then over here, we've said, we just basically pass it the order of the columns that we're interested in. So instead of the previous one where it was 1, 2, 3, 4, 5, 6, 7, 8, 9, we said we want these three, and then we wanted to pull the last two over. So what are columns 8 and 9, these other two wild types over, and then put the rest next to them. So this is something you can always do. You can reorder them, and it's basically you're pasting the columns together in the order that you would prefer. I'm not sure that there's necessarily any analytical reason that this would be 100% necessary, but for me, just to sort of keep organized, keeping like with like seems intuitive. Once I have it in an order that I wanted, I went ahead and ran this as matrix. And so thinking back to the sort of second large topic, you may recall that a matrix within R always has one type of data within it. And in this case, we're going to want numeric data since these are not factors, these are just measurements. We're going to want to change it to a numeric type. And the reason I've left off the first column is this is the name of the gene. So you can see even within these top 6 or so that are visible on the screen that they include letters. So if we were to have included that first column, we would have, instead of winding up with a numeric, it would have said, oh, these must be character strings, these must be text, and it would have interpreted all of these numbers as text. So if we were to run them up, they would be in quotation marks, and it wouldn't be able to do math. We couldn't add 35 plus 40. It would think of them as sentences containing letters that to us would mean 35, but to the computer would not be mathematically intelligible. So that's why I've gone ahead and just said columns 2 through 9, so sort of excluding that for the time being. But fortunately, we still have that data, and so that's in the first column. And so I'm using a command called row names. And basically what that does is from a visible standpoint, we can see it has kept that data, so add it back on as a name, sort of in the same way that we have the wild type and knockout types up here. But it's not actually part of the data in the sense of that we could use it for, arithmetic. We're not pulling it into the functions. We're just using it as a reference to reference the first through, and there's a lot of columns in this. I want to say, 50,000 columns. So it's a pretty big CSV. I'll also note, depending on the computer you're working on at home, certain things you might do, it might get bogged down. Try to avoid that by taking kind of smaller subsets going forward. But that is something to be aware of, that there may be times where you get kind of bogged down with just the wheels spinning today. So now when we check the class again, we can see it is a matrix. We feel good about that. And now when we check the first column, it's numeric. Again, important to note, the first column now is this column. This is just the row name, just a label column. So this isn't actually a column of data at all. And so numeric, that is where we want it to be. And similar to how we did in the first session, just want to get a quick bird's eye view. So I just did summary. These figures aren't really meaningful, but it is just helpful for me to get a quick sense of, okay, what's the general just, is there a median? Are there lots of NAs? And as far as I can tell, there are no NAs. So that's a nice thing to be aware of. So again, as we have in the past, we're kind of just getting a sense of what's in our data. So it might be the case that you want to get a subset. And so if we wanted to break those out, we could say, for example, the knockout we saw were columns 5 through 8, or 1 through 4 would be the other options. So we could pull those out. Perhaps we want to keep everything in one giant item. See, there's a column. When you do as a matrix, does it keep the column names? It does, because those are column headers. They're not. So if we had read it in, when we did read CSV, we said headers equals true, and that's sort of the default, so we don't always have to specify that. But sometimes you'll see another way of reading in data. You could also do, for example, import data set. So if I did this from, say, Excel, I'm not going to actually do it, but you do have to make sure that the first row as names is checked when you do that, if you have that. Otherwise, you will have to do a similar process to how we separated those row labels, because if the first column is interpreted as data, so if those pan1, WT, and so on were interpreted as data, it will read them as text. So you can have headers, but R has to know that in your data frame, those are headers and not part of the column. And whoops. Yeah, so if we were to look at, say, the first column, I already have all this sort of read in. Make this a little bigger, it's being a little slow. So if we said, what did I call it? The other one, Dolga Mat 1. We can see it has it as a header, but the actual values in that row are all zeros. So in a previous session, we also talked about the ability to use logical statements and combining those with the operators that are in R. So right here on the screen, we can say maybe we only are interested in looking at expressed cells of this the spreadsheet. So this number was chosen pretty arbitrarily by me. Again, you as the subject domain experts will have a better sense of what would be a meaningful threshold for your sample. This number is totally out of left field and was basically chosen more or less because I saw in another example of doing the same. And also in this case, it did not result in too large of a data frame. So for the class purposes, there won't be too much literal wheel spinning. So just to sort of run through though, what it's doing is the first thing it's doing is saying, first we're saying, is our row sums, so is the sum of a given row greater than 15,000? So if we looked at that spreadsheet, I'm not even sure if I have it up, just for the sake of argument. I think I've actually, I have not done that there. So it's saying if we were to add up all of these, is it greater than 15,000 and so on, going down to each row. And so as you may recall from a previous session, saying is the sum of a given row greater than 15,000, that's a logical question, meaning that can be true or false, or yes or no, essentially. So we're saying, is a given row greater than 15,000? And what R is doing is it's running down each row. It's giving it either a true or a false, so yes or no, essentially, a 1 or a 0. And then we're going out a layer and we're saying which. And so now it's saying, don't worry about printing out all the 1s and 0s. Now I just want the index, so basically the number of the row that applies to. So again, if I just look at that Excel sheet, it's saying if this one happens to meet that criteria, row 215, make a note of that. So that is what the which is doing. And then I'm going one step further and I'm saying, what is the name that goes with that row number? So first we're saying, does the sum of this row be greater than this, true or false? If so, which of these is true, is actually greater? And then going out a step further, what is the name of the thing which is greater than 15,000? So if we go back, that would be equivalent to pulling out, say, this for this item. So this column A 215. I think this actually is one of them. And then what we can do is we can sort of pass that to a variable. I've done something I just noticed now, which I do not sort of endorse. I've been inconsistent in switching between the arrow and the equals. I do tend to prefer the arrow, but so it goes. Sometimes errors happen. So passing this into some variable, which is basically just a long list of names from that first column that's off to, well, it's not the first column, excuse me, that's labeling each of the columns, each of the rows in our matrix. Then what we can do is we can actually take that list of names, that list of gene names, and we can actually pass that in the, thinking back to how we index things from maybe the first or second week. So we can see the list of names, comma, and then every column after it. So R is smart enough to take the names and say, okay, does, in this case, 17,00017, so on, RAK, does that match my list? If so, put that in this, expressed data frame, put this in this expressed knockout, and so on matrix. Sorry, I just said data frame, but really I meant matrix. So that way you wind up with just a matrix of the values that have met our threshold. So there's kind of a lot of layers, even though this is a pretty basic thing, but for sort of limiting down what we're doing. So again, just sort of taking the total, checking to see if it's greater than some threshold that we're interested in, seeing which rows are of interest, and then finding out what are the actual names of the genes that we want. And then we could just use that in our indexing, that list of names, to only pull out the names that we want. And that way we don't have to worry about, all of the things that maybe aren't of interest today, since there are thousands of rows. So going down just a little bit, whoops, jumping ahead just a little bit. So the next thing I'm doing is using a library. Again, this actually does come from Bioconductor, ComplexHeatMap. So I just realized I do not actually have the Bioconductor code in here. I think I had meant to get that. Because it is something that you're going to want to get from the BioC manager, not using the install.packages. And the reason, again, being if you have an R installation newer, I believe in 3.5, it can create problems. So again, if you don't have that installed, I would recommend Googling Bioconductor and finding ComplexHeatMap there. And they will have code that will say something to the effect of, if BioC manager installed, and then pulling from BioC manager the ComplexHeatMap. I'll definitely say there are, if you look around online, there are a lot of different options for heat maps. There's a base heat map that comes out of the box with R. There's heat maps 2, 3, and so on and so on. And so I think ultimately the different features, you can definitely find tables explaining the different features, and they may have elements that are more or less appealing to you. I, again, have kind of, not quite arbitrarily, I've chosen this because I saw somebody else using this heat map option, and I felt like that was a good way to go. And again, I think that will actually probably be the rule rather than the exception for how things are done. There will often be a lot of ways you can choose to do a thing in R. So just bear in mind, you may see another option for heat map, and you may choose to use a different one. So this is one of many options. And if I scroll down further, so let's just try out the basic heat map. Somewhat, maybe, I'm not sure if confusing is the right word, but so the base R heat map is lowercase heat map. The uppercase heat map is ComplexHeatMap's heat map. So I've now said the word heat map too many times. But if we just run this ComplexHeatMap's basic function, heat map, on our expressed Dolga matrix, we can just sort of really get a quick sense. Probably not too useful. We see every gene name is crammed together. We can see a bunch at the top using its sort of basic grouping. They've put the most expressed at the top, but we're probably not getting a whole lot of information out of this, aside that we can see that there's some range, which probably we could have guessed to begin with. But we could try it out for the other ones. Maybe some big trend will jump out, maybe not. But just to be aware of that, that is an option just for getting a very quick sense. So similar to last week, Heatmap, like the other functions, like pretty much all of the functions, if not literally all functions, accepts arguments. So in this case, it may not make sense for us to cluster the columns. We might not want to be moving around the specimen types. We might just want to keep those in the order that they sort of came in. So one thing that that Heatmap does, and if we want to even see, just because it has a pretty good documentation just in the system, we can see that it gives quite a bit of flexibility for adding the types of labels we want. So you can add both the row names, or you could add, for example, like a row title. So you could say, in this case, gene name, say, just to make it a little more presentable. Going down different options, you could do the same for for the columns, but as well, you could make decisions for how you want things to be clustered using the out-of-the-box options. So there are things like you could do clustering distance by Euclidean, for example, going down, so on. If you want the names to appear, great deal of options, as well as what it's expecting. So the matrix and the column, the colors, and so on. So again, just sort of pulling that up to highlight that that is available. There's also, in this case, we may say what method from the out of the box methods for the row clustering do we want. And so in this case, I've done complete, and I've just sort of left the row names off just because it was so overwhelming. Just sort of doing something similar for the other options and going down to the bottom. So we might want to do something more, that might be transforming our data in some way. So maybe we want to look at the correlations of our gene expression. So one option we could do is, here we're sort of running two levels of transformation on our data before we are looking at it. So one is, first is this T means transpose. Transpose is just going to mean basically flipping the orientation. And here we can see that this, this heat map is actually sort of a mirror image of itself. So something useful to be aware of. And then core is going to be correlation. We'll talk a little bit more about various options for different sort of hypothesis tests going forward in a future session. But then we can say, perhaps we don't want to see the column names or the row names, but we can still see the dendrogram that it's sort of automatically providing. I'll also note that I sort of stole a lot of this code from Dr. Itai Yanai. And I will say that is probably also kind of the rule and not the exception. A lot of the coding you will do going forward, you'll find somebody who's done something that works, and you'll basically adapt it for your own process. I mean, that's sort of the whole, that's by and large kind of how like a site like GitHub works. People are finding things that work to meet their need, uploading it and doing things. And so it is good to be aware that you don't have to reinvent the wheel for a lot of things, especially if you're doing something that maybe you're not exactly the first person to run a t-test. I mean, you're certainly not the first person to run a t-test. So it might be good to see how somebody else did it and kind of mimic their code in your own project, and then update it with your variables and your commands. So we might want to just actually take this, to sort of break it apart, take this correlation and give it a name. I have just stolen this letter C. I will say, if I was being maybe less lazy in my adaptation or theft, I might have given that a little bit more of a descriptive name. But for today's purposes, we won't worry too much about remembering down the line. But it can be helpful to be somewhat descriptive. You don't want to, of course, write like a sentence long variable name and then be annoyed at yourself every time you have to write it in. But so we're getting the correlation, and then we're just saving this heat map. So this is literally the same exact thing, but with the row labels. But again, that's too much for anybody to make sense of. There is an option. It won't really actually be that effective with a heat map per se, because there's so much. But I do think it's worth just noting. Let's just do, I think I actually still have this in here. So let's say we look at the heat map. We go to plots. Something good to be aware of, especially maybe for something a little smaller where there's not going to be 100 rows, is this zoom option. It's taking its time. Hopefully I didn't just crash my R by feeding it too large of a thing. And the zoom option will basically pop out a chart or a figure that you have in your project, and you can then sort of expand it. And so yeah, let's let that go. I'll even try it here. Let the wheel spin. It's being a little slow today. I've really been irritating my computer today, so hopefully that opens up sooner or later. Normally it is faster than this. But yeah, basically you could stretch it out, and if there were labels that maybe were on top of one another or were being hidden, oh yeah, so there's a question, what is core? Core is sort of a generic correlation, so you can actually do it you could pass it, for example, like the Pearson or Spearman methods, and it's, yeah, a correlation. Sort of reloading. In any event, the real take home here is that this zoom option that exists above the plots can be nice, especially if things are sort of either on top of each other, or maybe sometimes it sort of auto cuts off some of the labels down here. You can get a better view than you would have otherwise been able to get. All right. So you may want to be more active in how you're actually hierarchically clustering your expression data. And so there's sort of, I've got kind of two nested commands here. So we've got hclust and dist. And so what this is going to do is basically, first we're going to say, how do you want to do your clustering? And then dist is going to basically be passing it one method of several. So if we actually just look at dist, we could see basically what it's sort of doing is it's translating these values on the back end into a distance matrix. It's sort of saying, if you could imagine that each value is being plotted, how far effectively are they, using different sort of methods of calculating that distance. So it might sort of be doing it in the, I think the default might be Euclidean, though. So it's sort of similar to how you would use like geometry basically to find the distance between items and going between two coordinates. That said, the coordinates, so to speak, they don't have to be two-dimensional. It's not like they're literally being charted. And sometimes, it will be the case that they are very complex in their dimensions. So they can be hard to sort of mentally visualize, but we don't actually have to mentally visualize them. As to the merits of the different dist methods, distance matrix computation methods, that's really something I cannot personally speak to, but just sort of making you aware that there are these different options that you can use, different methods, yeah, they list some out here, that you could use for sort of creating your hierarchical clustering. And then you can also use that clustering to make decisions about where you're going to basically, like the command is cut tree. And so you could think of it like, if I scroll up just a little, sawing it through. You can actually do it by height or by the amount of groups. So if you see, I have k equals 6, it's basically saying do 6 groups. But you could also say of a certain height within this for how you want to be kind of grouping things to then view. So then this actually is not, strictly speaking, totally necessary to have this complex heat map : heat map, because we already have heat map open. And so it will know to library loaded, and it will know to use that heat map. But now we can use the order that's being passed from the clustering, and we can also add an annotation. So we can kind of see the clusters that are coming about as a group. So you might be saying, why 6 groups? And in this case, again, somewhat arbitrary. You may feel that it makes more sense to have more or less groups that will be more or less useful for your analysis. And I think that's going to kind of come down to, by and large, a major part will be your professional insight and background and opinion. But it will also, I think, come down to the actual data, as well as a fair amount of exploration to kind of get a sense. And that provides that annotation over here. So it's sort of providing what it feels are the groups over here. Did I skip one? I don't think I did. There's also, I'm not sure if I made it in time to get it into this slide deck, but there is also an option for doing what's called Kmeans clustering. So it's sort of a machine learning option. If you just search Kmeans, gives you information about that. The actual function from our side as the user side is not going to be all that complex. So we could do, for example, Kmeans. Let's do expressed KO, for example, 10. We could do histogram. What was it? Whoops, X must be numeric. Oh, whoops, I've done the wrong thing. I've deleted the wrong thing. But in any event, Kmeans, that's definitely something you can explore as well. At times, you may also want to perform other transformations of your data. So we've got a highly skewed data set, so perhaps you want to sort of pull things in by seeing the log. If we do transform things by the log, often it can be helpful, especially in this case where we have a lot of zeros. Pulling that up again. So we may want to add a 1, so a small value. Won't really be enough once we take things on the log scale to change the meaning of those values, but the log of 0, I think, is it an error or is it negative infinity? Now I'm totally blanking, which I think is how it goes when you're talking in this setting. But yeah, so you'll want to add 1 to not have that kind of problem that the log of 0, actually, let's just find out. Negative infinity, great. So yeah, you'll want to just add that 1. That's why we do that there when we do that kind of transformation. And again, that's just done because there's such high values and such low values to sort of pull them on a scale that's going to be a little bit more manageable. And you may also, you could combine things into things like for loops and if else statements. So if you're just trying to find things that are, for example, highly correlated, another option building on what we did previously. So we could set up, we kind of talked about this at the end of the for loop. So we could set up this blank vector. We could say, go through every row of our expressed data matrix and say, if it's, if these two sets, so if the wild type and knockout are correlated over 0.7, so that would be pretty highly correlated, go ahead and print that correlation to this value and then add it to this list. Otherwise, give it a 999. So going forward, we'll do a session on data cleaning and how you can treat things like if you've coded your missing values as 999, or if you have NAs, ways that we'll be able to make our data a little bit more neat so that we can actually run analysis. Since that often these sort of, what's the word? They may not feel like it's a part of the actual data analysis, or you may not think of it, but the data cleaning can be a huge time commitment. I think often probably it almost feels like that's like where the bulk of your time is going, just getting it to the point where you can do some sort of analysis. So thinking about things like how you're going to treat missing values. And then we could, similar to how we did before, we could say, we could use that which. So we're saying that's basically finding the index for anything where it does equal 999. And we'll talk about these sort of methods more. You could also try things like na.omit and really get rid of those outliers. So if we wanted to see this, what we've just put together, we could see where the correlations lie. We could also, again, add one of the sort of built-in clustering methods. And again, if you are interested in what those might be, we could say Heatmap, forget the others. I know complete's in there, going down, and so on. But good just to be aware of those options. It's also possible to do some customization of the view. So the default was this red and blue, which may be fine. Perhaps you have a journal that's making different specific requirements of your coloration. So hopefully for Heatmap, it won't just be black and white, but certain journals do have different requirements. And so in this case, let's say it was only supposed to be in one sort of scale of color. I've used a package called rColorBrewer. This one I like because it has a setting where you can view only colorblind safe color codes. So I'm not sure actually if the red-blue is a big risk for colorblind safe viewers. I know red-green is a very common colorblind issue, but it can be good just to be aware that there are sort of these out-of-the-box options for color safety or color accessibility. If I wanted to, for example, let's see, R Brewer display, I think, is that what it is? Or library, rColorBrewer. I can even actually just do rColorBrewer just to remind myself of what the command is. Yeah, display display.brewer.all colorblind friendly equals true. It's a little bit small, but if I was to zoom in, you can see they've put together these things. To be honest, I'm just sort of trusting that they actually are colorblind safe. I had a colleague who was colorblind who said, yeah, they looked more or less, legit. Oh, it's because it's in the other tab somewhere. Yeah, oh no, that's this. Well, it's gone missing, but in any event, the zoom, oh, here it is. Nope. Oh, that's this. Oh, yeah, here it is. So yeah, you could actually see these. And you can choose to use a palette that can be a little bit more color accessible for your work. So in this case, we've just said, we've made our heat map, and then just adding call for color equals brewer.pal, how many gradations. So maybe we want more, maybe we don't want to specify, but we could say 7. And then I went with the quote BUGN, which again, if we pull that up is, I guess, this one. But again, maybe your journal is saying our figures can only have, 4 gradations of color. Maybe I hope, again, hopefully for the heat maps, it won't be the case that it will be black and white, but it is often, at least in my experience, the case. So maybe a shading like grays. And that way it also kind of takes some of the guesswork out, at least for me, when doing coloration, if 2 grays look too similar, just sort of trusting, okay, this will be more or less usable and I won't have to worry about it so much. Since I think we've probably also all seen figures where the person thought that they were working in color, and then it was like maybe a fee for printing in color, so they did it in black and white, and it just looks like a giant gray blob. So good things to be aware of. Oh, here's, of course, now after we sort of ham-fistedly talk through it. So a similar thing for Kmeans clustering, for the unsupervised clustering. So if that's something you're interested in exploring, you could also look at that. Basically what it's doing is it's passing through iterations. It has these numbers and it sort of has them not literally plotted for you to see, but it has this matrix of the distances, and it's sort of saying, okay, these over here are group 1, these over here are group 2, and sort of running this through until it has sort of mechanistically categorized them. And so that may also be an option for your clustering. And I think probably this will be a topic that's addressed in greater depth as to the why and the conceptual framework. And on the Tuesday, the 28th, starts the real R, not the real R, the real RNA-seq instruction. So there will be more discussions of kind of the why, whereas today we're really focusing in on that kind of how you might do these things. So building your matrix, so finding things like the correlation of expression values, and then setting those values for your clustering to then use for analysis. Let's see. Just gonna check the chat before we sort of, I've gone through a lot of things definitely very quickly and hopefully not too confusingly. I'm hoping sort of before we jump into a new thing, I do see, yeah, the chat, colors are important and definitely take a long while to get right. And yeah, so I will third that. Yeah, I'll definitely also to add on to the comment that's in the chat saying maybe avoid using the default R colors. I'll also say a lot of the defaults, both I think are ugly, but that's kind of a judgment, so whatever. But I think there is also this problem that the default plots will weigh down a lot of what's called visual load. So there's this idea that kind of the more things that your eye is more or less taking in and interacting with, the harder or slower it is for your brain to be able to pull out insights quickly. So a sort of low-hanging example would be, I'm sure we've all seen like Excel plots where it was like 3D for no actual reason. It's just a bar chart, but it's 3D of all of the bars. And maybe the background's like a heavy gray and the main label is like really intense. And so like you just read the main label and then the rest, your eyes are swimming. Versus there's a sort of an alternate approach that a lot of kind of, like leading experts, I guess, in the data viz universe prefer or increasingly prefer, where it's more of a kind of the less is more approach, with the idea being that kind of the less visual information that your eye is sort of processing and that your brain therefore is processing once it hits the eye, the faster and more intuitively you can understand things. And so the default, for example, the default chart setting in R is going to have this kind of heavy gray background. And so if you buy into this idea that, that your brain is spending time processing that, there's really no reason to add that extra layer of kind of understanding or having to comprehend what does that visual element mean anything, or is it just like shading? So I think I'll also give just a moment to see if there are any other questions about matrices in the chat box. Again, bearing in mind that my background definitely is not primarily as a bioinformatician. So I feel like I could conduct these things, read the code, explain what we're doing with our existing code. But in terms of the why, a lot of that is going to come down to, for example, where we made those cuts for our clustering. So if we go back to here, we said that we were doing it 6 groups. So where you do that, or if you choose to do it at a certain height, that's going to be kind of what makes sense based on your work for further analysis. And basically those clusters you'll then use to sort of say, are they expressing at different time points or in different ways with different conditions? And is that scientifically meaningful once we sort of move past the, reading and exploring? Can we then make meaningful comparisons and meaningful sort of statistical analyses of those groups? Are they actually, does this express more in, condition A versus condition B and so on? And that will again be discussed much more in depth going forward, starting the 28th. Okay, so for the remainder of today and going into next week on Tuesday, we'll be talking about a package called Gplot2. The reason I'm going to be talking about it is basically, I won't say everyone uses it, but it definitely feels like a very prevalent data viz package, to the point that almost every, how do you do thing X that at least I see within the realm of kind of standard charts. So I know last week there were questions about like making bars with error bars, or kind of the standard types of figures you'd be probably used to seeing in a paper or on a poster. Often you'll find the guides explaining it in Gplot2. And it has a lot of nice features for kind of getting your figures in kind of a publication-ready format. That said, it definitely also requires a bit of a different way of thinking about data visualization than you might be used to. And we'll really break that down in a moment. So do want to sort of give the caveat that it can be kind of a weird learning curve, but then the flip side is it does have a lot of nice features. And then I think, unfortunately, once you're sort of in that mindset, it can be hard to feel like spending the time to relearn, like how do you change the labels in like the base plots, for example. So again, so if you don't already have it, go ahead and do install packages, Gplot2 in quotes, library Gplot2. And so the thing that makes using this package kind of different than you may be used to thinking about data visualization is, let's say you were just building a chart in Excel as sort of a basic example. Typically there, you might highlight column A by column B, and then go up to the top and say, make a chart and give me a bar chart or a scatter plot, say. And it will produce something. Maybe it's right, maybe it's not. Perhaps you had the experience in that case, if it's not what you want, it can be a little bit frustrating to get it to change because it really kind of just wants to give you the out of the box thing. Here, there is no straight up out of the box option. And instead, it's really going to work in a couple steps using layers. So if you can get your mind thinking about layers of information, I think that will really help for working with Gplot2. So the first layer of information is just going to be straight up taking our data and mapping it in some way to a visual element. So in this case on the screen, we're saying to think back to our previous data set, let's map our X values age and our Y values cholesterol. You don't have to have multiple, and you could have more than one. So you have to have at least one, otherwise you're not doing anything. But you could have many values, and you could even start to think about, okay, maybe I want to encode values for shape or for color or fill, or for that matter, you don't even have to have those be meaningful. You could just assign them. But this first step is just going to be, we have ggplot as a command, some data object, so in this case a data frame, NYC, and then what's AES, so saying take some element of our data and map it onto this aesthetic command. So it's saying our X values will be this and our Y values will be this. So bearing in mind that there's no inherent visual quality to our data. It's just a table of data with columns of, in this case, age and cholesterol. So we have to really spell it out for R, whereas a tool like maybe Excel or GraphPad Prism, to a certain extent, is going to kind of try to guess, okay, you've given me two values, so maybe you want a scatter plot. So I'll just try to map it onto an XY. R is really going to ask you to spell that out. And again, that's going to be in that AES step. So if we try to run the AES step, we get basically nothing. On my screen right now, it doesn't look too heavy. Sometimes I see this gray background. It's like very deep gray. So your mileage may vary on that baseline. So we can see it understands, okay, you want to do something with these values. Again, cholesterol, Y, age, X. But we then have to add more layers. So right now, all we've just done is said what we're eventually going to be using is our baseline layer, taking it from the realm of a straight up table of data and moving it into the realm of something that could be visualized, giving some sort of visual instruction to the program regarding the data. So what we'll next need to do is apply what are called some sort of geoms, so the geometric object basically. And the most common way that I've often seen is that you'll see your baseline instructions. So in this case, I've assigned that base layer as pick. You could also just do ggplot, nyc, AES, and then plus geom point. It's really up to you. And in this case, we get a scatter plot. So geom point is that figure. So there are a lot of these geometric objects. So similarly, if we tried geom smooth, it gives us some information about the smoothing technique. It gives us this curve here. And something important is there's absolutely no need to memorize all of the geoms. And actually, sometimes they even update, and it's annoying. And something that did work seems to no longer, it does something slightly different. So an option here is if we go, actually I don't want that quite as large, so I want to be able to see my help window. If I go up to the help window in our studio and scroll down to cheat sheets, the program basically installs these or downloads these nice PDF cheat sheets that are available for different packages that you've installed. So here we're going to choose the one for Gplot2. But if you wanted, as you can see, there are these different options. So we could view them actually just for this development tool, the IDE that is RStudio. We could see them for our markdowns, which is what this is, what these slides were built in. But for right now, again, for Gplot2, mine's set to just open in my browser. And they provide a really nice sort of breakdown of the different shapes that basically can be applied. And they try to break it down by useful categories. So 2 variables, for example, going down, 1 variable. And so that these can be really helpful things to be aware of, that you don't have to memorize all of these options. Bar plot, for example, I think there's somewhere in here we could find error bar. I think did it find it? Saying it found it. Visualizing error. Okay, yeah. So you could do things like geom error bar. And here it's saying, you could give it a y maximum and minimum, for example, for the x values and so on. So it's asking for these specific types of information. Though often some of these values, as we've seen on the previous page, on this previous page, we can often add these as kind of blank instructions. So it's just telling it to use some value, some visual encoding. So using that same picture command from 2 previous, and we could try out different options if we wanted. So there's a question about if you have to define for example, I'm guessing like the curve instructions. And if you wanted to provide it more instructions, you could actually even do that in those parentheses. So some different options will give different things. So actually this next one's a great example that's maybe a little simpler than the curve. So in this case, let's say we wanted to make a histogram. So you may be saying, okay, well, last week we talked about you could make histograms just by typing hist, and then, for example, cholesterol total. And for exploration purposes, that may be fine. But if you want to really customize that, it can be a little bit annoying to work with. So that's where a tool like ggplot can be nice. And so we could say here it's doing just the cholesterol total, and then it's taking this kind of special character. It's sort of not necessarily typical of the R syntax, but just saying the count of the different cholesterol totals. It's hard for me to guess what the level of bin width is, but we can actually go ahead and set that by giving it a command to the geom bar. So let's say we want the bin width of this one to be 20. And again, that I've done somewhat arbitrarily. You may have something more specific or some actual mathematic reason or a reason based on your field of study that makes doing different widths, make more or less sense for those figures. But in this case, again, so we can see the real take home of this should be that often these geometric objects, you can pass them commands that can then further specify based on the type. Of course, things like bin width won't make sense for the point command. That's very specific to how wide the groupings are. The bin is just the grouping in the histogram. Whoops. And yeah, and you can sort of play around with it as you see fit. So also the possibility, so let's say instead we wanted to try box plot, so similar to before, but now we're just saying separate your x as, your x, so going horizontally here, just separating out those two factors. And again, doing that range so we can quickly see again our median and our quartiles for the cholesterol levels. From my sort of quick eyeballing, those look to be roughly equivalent for those two groups. So there's about 5 minutes left. Sort of can see we've got some information on formatting. I'm a little bit hesitant to jump into a new element of this as we sort of have just a few minutes left. So I think I might just sort of leave the last few minutes for any questions, or if there are not questions, give you time, 4 extra minutes with your afternoon. That said, I again will ask, please reserve the chat for any questions you may have and not for any messages like goodbye or that sort of thing. While we appreciate the sentiment, it'll make life easier for our people. Oh, something else I'll mention as well. So yeah, so we've got thank you for posting the link on for where you can find things, but I'll also post these 2 guides that were forwarded over by Dr. Fenyo, which may be of interest to you for sort of getting a sense of some ideas about data visualization. We'll touch on some more of these kind of best practice ideas that might be useful to you in your visualization practice and your data analysis practice next week, as we dive more into those data kind of formatting features that come with ggplot, which, to be honest, for me is really where it shines beyond the kind of out-of-the-box base R packages. And the other thing I've mentioned a few times, but just so everyone's fully aware, the RNA-seq portion of this will begin on Tuesday, the 28th. So we'll be leaving behind the R instruction and moving into the RNA sequence analysis discussion. I'll probably still dial in because I'm also interested in learning. So the next week or so, we'll continue to discuss data visualization. We'll touch upon some kind of what might be thought of as like bread and butter hypothesis tests and just how you could do those. So an example, which I should have explained more, but like the core example for doing correlations, as well as we'll really try to take a deep dive into data cleaning, which again, we've looked at sort of tangentially, but I think will be a major part of your lives going forward. So I'll be with you for the next week, and then Tuesday the 28th, it will be moving over to RNA-seq. So thank you for your time, and I'll see you all Tuesday.